Hello again, we are solving A-levels physics past papers. We started with ACE physics, and this is our third topic, that is electric circuits. In this video, we'll be solving 5 multiple choice questions. And these questions are very basic, and I don't want to make separate video for each topic. So I've combined all of these small topics, like for example, ohmic and non-ohmic conductors, LDRs, that is light dependent resistors, and all of similar topics. So I've combined all of these topics in this one video. So we'll start with the first one. The question is, a hair dryer is used for 3 minutes. The operating current is 6 amps. What charge flows in this time? So this is just the definition of current. We know that current I is charge Q divided by time. So we know what the current is. We know how much time we used the dryer. We can just rearrange this equation for charge. It will be current I times T. So current is 6 amperes multiplied by 3 minutes, but you have to be careful. The units for current are amperes. And if we are using amperes, that means that for charge, we are using coulombs. And for time, we are using seconds. This is the definition of amperes, coulomb per second. So it means this 3 minutes, we have to convert 3 minutes into seconds. So you have to multiply it by 60 seconds. So now current is 6 amperes, time is 3 minutes, and each minute has 60 seconds. So you multiply all of these and you will get charge, which should be 1080. That is option D. The second question is, the graph shows how the potential difference V varies with current I for a circuit component. Which of the following could be the circuit component? Now, I will not make another video for all of these components, individual components. So I'll try to explain the graph and functions of these components in this video. If you already know the function and graph for these components, you can just skip to the next question. That is question 3. Okay, we'll start with the first component, that is a diode. A diode is an electrical component that looks like this. And the function of a diode is that it allows the current to flow in one direction, but it stops the current in the opposite direction. So in case of, for example, AC, that is alternating current, when the polarity of the voltage is such that this side is positive and this side is negative, so the current will be flowing in this direction. This diode will allow the current to pass. But when the polarity changes, like this one becomes negative and this side becomes positive, this diode will not allow the current to flow in the opposite direction. So you will not see any current in this cycle of alternating current. Also, the graph for a diode looks something like this. So you have voltage V on x-axis and current I on y-axis. So the graph for diode looks like this on the positive side, and on the negative side, if you keep on increasing the voltage, the current will not increase. But if you increase the voltage to such a high value that this circuit component breaks, so then the current will shoot and the graph will look like this. So you can see in the positive direction on this side of the voltage, the current is increasing linearly. And then again, if you increase the voltage beyond a specific value, the current will shoot. And for negative voltage, the current will be almost zero. You will see some current. This is called leakage current, but it's for all practical purposes, this is almost zero. And then if you increase the voltage beyond a certain limit, this is called the breaking point. This circuit component breaks and then the current becomes infinite. Okay, the next component is filament bulb. The difference between filament bulb and ohmic resistor is that for ohmic resistor, let's look at the graph for ohmic resistor. This is V, and on y-axis we have current I. Ohmic resistor is any electrical component. It can be a wire, it can be a resistor that obeys Ohm's law, V equals I R. So the graph you can see at the equation, this is a linear equation. The graph for this equation will be a straight line, and the slope, or in this case, the inverse of slope will be the resistance R. And you can see that since the slope is constant, the resistance is constant for ohmic resistor. So that's why the graph is a linear straight line. But in case of filament bulb, what happens is that if you increase the temperature of the wire, the resistance also increases. So this is normally what you would expect from a conductor, because what happens if you increase the temperature is that the kinetic energy of the atoms increases, right? And as a result, the electrons experience more collisions, which means higher resistance, right? So this is what you should have in mind, that if you increase the temperature of any conductor, the resistance will also increase. So this is what happens in filament bulb, and therefore the graph for filament bulb looks something like this. So the voltage and current I on y-axis. So initially the current will increase linearly, but when the temperature of the wire increases, the current will become constant. So it will go like this, and this value, let's call it I max. And the reason, as I explained, is that when the temperature increases, the resistance also increases, and because of this increased resistance, the current cannot increase linearly, and that's why it becomes constant. So this is the graph for filament bulb. Now the last one, thermistor. This is a temperature dependent resistor, and you should always remember that if it is not mentioned otherwise, you should always assume that thermistor is a negative temperature coefficient thermistor. So what does it mean to have a negative temperature coefficient? It means that if you increase the temperature, the resistance actually decreases. So this is what it means to have a negative temperature coefficient. So thermistors have actually a negative temperature coefficient. In that sense, this thermistor is different from a normal conductor. For normal conductor, if you increase the temperature, resistance will also increase. But for thermistor, if you increase the temperature, the resistance actually decreases, right? So you can also guess what the graph should look like for a thermistor. For voltage, for current as a function of voltage, the graph, since here you can see if the resistance increases, the current becomes constant. But for thermistor, it is actually the opposite. So when the temperature of wire increases, the resistance actually decreases, and as a result, the current will increase quadratically, or you can say infinitely, because the temperature decreases. So you can compare these two graphs. This is for a thermistor and this is for a filament bulb. By the way, filament bulb is also called non-ohmic conductor. So non-ohmic conductor and filament bulb both will have the same graph, and this is thermistor. The graph will be the opposite of filament bulb or non-ohmic conductor. Okay, so coming back to our question, we have a graph for voltage as a function of current I. Now that I've explained all of these components and how the graphs look like for these components, can you answer this question? What is this graph? Which component can it be? Now the tricky part is that they have swapped the axes, so you have to be careful. This is voltage and this is current. Normally what we do is we plot voltage on x-axis and current I on y-axis. But here voltage is on y-axis and current is on x-axis. And if you compare these graphs for the ones that I drew, you can see that the current becomes constant in this graph. And here you can also see the current becomes constant at some value here. So this is the graph for a non-ohmic device. In other words, this is filament bulb, that is option B. The next question is a light-dependent resistor, we call it LDR, and a negative temperature coefficient thermistor are connected in series. Which of the following combination of illumination and temperature will result in the highest combined resistance? So we know that if resistors are connected in series, the combined resistance is just the sum of individual resistors. So R1 plus R2 and it goes on. This is R equivalent. This first resistor is LDR, that is light dependent resistor. This second one is actually a thermistor, and I have already explained that thermistors have negative temperature coefficient, which means that if you increase the temperature, the resistance actually decreases. So to get the highest combined resistance, because they are connected in series, we want to maximize this resistance and also this resistance. So how can we maximize the resistance of LDR? We can maximize it by reducing the amount of light, which means by making it dark. So we can see dark in the first and in the second option. Now to maximize the resistance of thermistor, we want to decrease the temperature so that the resistance can increase, right? So we want the resistance to be cold, not hot. This is wrong. So the correct option must be A. Question 4 says the diagram shows a graph of current I against potential difference V for an electrical component. Which of the following components would produce a graph of this shape? You have to be very careful. At first look, this graph looks like this one, and this is the graph for a diode. But if you look closely, the current in the opposite direction increases without being zero for the first few values of the voltage. So this is not a diode, okay? As you can see, if you apply the negative voltage, the current suddenly starts increasing. So this cannot be a diode. This is actually a negative temperature coefficient thermistor. So what's happening here is that if you increase the voltage, the current increases, and because the current increases, the temperature of the wire also increases, and when the temperature increases, the resistance decreases, and when the resistance goes down, the current starts increasing quadratically instead of linear increase. And same happens in the opposite direction. So this is a negative temperature coefficient thermistor. Finally, the last question is, a cell is connected across a resistor. After a while, the internal resistance of the cell increases. Which row of the table correctly shows the change in the current in the circuit and the change in the terminal potential difference across the cell? Now, in the last 3 videos, I've already explained the topic of internal resistance in detail, so I will not explain it here again. If you don't know how to solve questions for internal resistance, you should watch the last 3 videos. So we have a battery and internal resistance, and this is what we call the terminal potential difference, which we get at these 2 points. So the question says that after a while, the internal resistance of the cell increases. That means that we are increasing this internal resistance, which means that the current will decrease. So it is either option A or option B. Now, what will happen to the terminal potential difference? We know that if you increase the internal resistance, this EMF, some of the potential will drop here across this internal resistance. We call it I times small r, and whatever is left will be the terminal voltage, right? This VT is the terminal voltage. So if you increase the resistance, internal resistance, this potential drop will increase. That means that the terminal potential difference that you will get here at these terminals will be smaller, so it will decrease. You can see it's option A.